This is the last video in the validity review, and the focus here will be on external validity, specifically the threats to external validity. So, ecological validity is how well does the environment or the setting of the experiment that's being conducted align with the generalized settings that the researcher wishes to generalize to. Sometimes this is called interaction of treatment and setting or reactive effects to experimental arrangements. Essentially, what's happening here is however the researcher sets it up doesn't match up with how it would really be done in the real world. So, for instance, I had a thesis student who did a brisk walking design where they were brisk walking for 15 minutes, and most of her participants didn't even walk a full mile. Well, if you're going for a brisk walk as your exercise activity or your physical activity, you're probably going to do it for longer than 15 minutes, so her study may have lacked ecological validity. Population validity is sort of the other coin to differential selection and internal validity. This again relates to the sample, but instead of looking at how it affects the dependent variable, we're looking at how well we can generalize. How well does the sample represent the population we intend to generalize to? Another name for this is interaction of treatment and selection. So in this situation with population validity, we want to look at who we have actually gotten from our sample and making sure that they really do reflect or represent the population we intend to generalize back to. The interaction of treatment in history, this threat deals with problems of trying to generalize for different periods of time, either in the past or the future. As studies get older, we're always concerned with this question. If we repeat the same study today, would we have the same results given changes in science and human behavior and so on? That's why often in our reviews of literature, we encourage you not to cite studies older than 10 or 15 years because so much has changed in that time that the older studies really might not be giving you the same you're building the argument in the way that you want them to, because their outcomes might actually differ if they're the same protocol we're used today. Reactive or interactive effects of testing. This is the one I was referring to in the internal validity video, or the validity review part 4. Here, again, we're concerned with the pretest, but what happens is the pretest makes us more aware of the treatment being used. Therefore, the treatment might only be effective if a pretest was used, and therefore we can't actually generalize back out to the experimental condition. So it might not be that we could the findings that we get might be due to the existence of a pretest, and in the real world we don't get pretests. We just might be offered a supplement, or we might be offered a new training plan without any sort of baseline assessment. So without that baseline assessment, if that doesn't trigger change, or if that's what's triggering the changes, then it might actually be hurting our external validity. Now, the way that we can test for that is using something called a Solomon design. And so to sort of show you what a Solomon design looks like, your regular true experimental test looks like this, where we do ROTO and then OO for our experimental group, and we randomize people into this. Now, we can do 2 additional options. We can do a three-group Solomon design where we give one group the treatment but no pretest and observe them to see if they significantly differ from this first one, or we can do a 4-group Solomon design where we give one group and they don't get the pretest or the treatment. And basically what we've then created is 2 groups here that are not used to answer our question, but only used to confirm that we don't have this threat of reactive or interactive effects of testing. Solomon designs aren't done very often, but they are, in terms of dealing with this threat, the best way to handle it. And then there's selection bias, interaction of selection bias and experimental treatment. Essentially, selection bias is people who choose to participate in your study because they're interested in your study. So if you are trying to do a study and you're asking different schools to participate, and the schools look at your informed consent and the protocol, and the first 9 schools you talk to say no, but the 10th says yes, what is it about your study that's perhaps not interesting to these schools? If it's something about your treatment, that's potentially going to make it harder to generalize, because if it's effective in that last school, we can't necessarily say generalize to the first 9 schools who said no, because there's something about those 9 schools and why they chose out of your study that may have actually been affecting your ability to generalize to them. And then there's multiple treatment interference. This happens when in repeated measures designs where people receive more than one treatment condition and we have carryover effects. We wouldn't have carryover effects in the real world, because when you generalize to the real world, we often aren't introduced to multiple different treatments. So that would affect our ability to generalize to the real world. So in this case, sometimes even though independent groups designs are less powerful and have less control, so therefore could hurt internal validity, it might actually help external validity in this situation. Other ways that you can control for external validity threats, obviously every study also has external validity threats. What can we do? Better random selection. So internal validity, the bigger focus is on random assignment. External validity, the focus is on random selection. Blind and double-blind studies will help here as well. Counterbalancing the designs to avoid the carryover effect can also be useful. Careful use of your operational definitions, that's the case in both. Making sure that we have reliable and valid assessments. And then we move on to our last area, which is statistical conclusion validity, which we sort of touched on many times throughout the semester. Statistical conclusion validity deals with the inappropriate use of statistics that could lead to invalid conclusions, or essentially interpreting our stats wrong too. This could be due to a result of lack of data screening, not meeting basic assumptions, not controlling for type 1 and type 2 error, and more. So a lot of the things that we've talked about that we've really harped on this semester, and really kind of understanding which assumptions are really important to meet, which ones aren't going to affect because of the robustness of the statistic, are important to be aware of. So you want to make sure that you use an adequately powered study. You can use G-power as an a priori power analysis to set you up. Use appropriate controls and procedures within your study. Make sure you're using the right statistics so you understand the rationale and all the different components. Then make sure you meet all the basic assumptions, and if you don't, understand if that's okay or not. Conduct thorough data screening for outliers, normality, missing data, equal ends if appropriate, and then make sure you carefully report the results of your study, dealing with whether or not you had to remove data, making sure that you discuss if you have non-significance, what does that mean, and so on. And that would basically be our quick wrap-up on validity to review. Please email me if you have any questions. Thank you.